What's up, everybody? I'm not a software engineer, but I did manage to make the same game in Unity, Unreal, and Godot. And so you've possibly seen the three individual videos that I've made on this topic thus far. But if you haven't, or if you're interested in a more thorough comparison, that's what this video is for. So before I jump into all of that, I'm going to play the actual demonstration of me playing all three of those games. I'm not going to say which engine is which, and if you're interested in maybe guessing yourself, now would be a good time to do so, but I'm gonna go ahead and pause it, jump right into the three different engines, and we'll be back to compare all three of them. All right, so spoiler alert, the first one is Godot, the second one is Unreal, and the third one is Unity. So I'm going to go ahead and kind of just jump into the start of this project. And the first thing I kind of did was decide to A, make this game because I was messing around in Blender, and B, I wanted to learn three game engines. I kind of had some experience in Unity and Godot, but I've never actually done any gameplay mechanics in Unreal at all. So I wanted to use this as an opportunity to kind of advance myself in all three of the engines. And so it made sense to kind of come up with some, I guess, criteria that I wanted to go through. So phase one, basically the start of the project, is to create a new game file and import my Cuboid model, which of course is a Blender file, and I will show that here. So here is the Cuboid Blender file, before we jump into the different engines. But basically, the reason I'm showing you this is because I wanted to get the same armature and everything imported into the three engines so I could basically make the character walk and jump, right? So if you actually go to the animation tab, you can see that, let's see if I can just play my walk cycle. So if I actually go down to walk and then kind of scrub the timeline here, you see this 28 frame animation. So I wanted to use again, the walk, the idle, and then the jump animation in all three game engines. And just to do just a little bit of compare and contrast here. So if you go back, or if you take a look at this slide, you notice that I have basically FBX and GLB, right? So FBX is the format that I used for Unity and Unreal, whereas GLB is the format that I used for Godot. Another interesting thing, and if we actually jump into the engines here, um, they all kind of have a similar state machine. So this is Unreal, this is Unity, and then this is Godot. And I think if we go into the actual animation tree, yeah, it all kind of looks the same, and I set it up pretty similarly in all three. But yeah, the big difference there is that I used a GLB file within Godot. One of the other things that I thought was worth mentioning is that Blender itself I had to basically modify my export for Unreal such that the meshes, I believe, were children of their corresponding bone, and that was for the skeleton to actually work in Unreal. I might have that wrong, but I had to do something with the actual mesh as to its parent-child relationship with the actual bone in the armature. Otherwise, it would not work properly. Whereas with Unity, I didn't have to do that. I basically just exported the FBX with the Unity settings and then just imported it without much issue there at all. But yeah, so as you can see, the state machine is it all kind of flows the same way. I will say that I did change up something for the Unreal one in particular, and you might be asking why. And that's actually the start screen. So if I hit the play button here, you can see that he's just entering this kind of walk state. And that happened like due to a bug or something like that in Unity, but I actually liked the way that it looked. And then for some reason, it didn't work the same way in Unreal. So I basically modified the state machine a little bit so that the start scene shows up that way. But anyway, that's about as much as I wanted to get into with the differences in importing the FBX and GLB files. As you can see, it is a little bit different, but by and large, they all have that similar state machine, so it wasn't too crazy. The next thing I wanted to talk about is the actual environment. So I'm going to go ahead and jump back to the scene and all three of the engines here, and then kind of just get rid of the animation stuff because we're moving past that. But if we go to the main scene, you can see here that the terrain does look a bit different in all three. Now it is mostly based on the same Gaia file, and if you're unfamiliar with Gaia, you can import it into Unity or Unreal or Godot and base a terrain mesh on it, or a terrain game object on it. So I'm going to open up Gaia really quickly just to kind of show you what that looks like. Yeah, so basically Gaia is a really neat application that I knew absolutely nothing about until I went down this kind of learning path. But basically you can create these nodes and connect them to other nodes. Or at least that's the nomenclature I have decided to use. And the first one is called Slump, which actually is responsible for the terrain that you see here. And what I actually did from, I guess, the Gaia 2.0 free version was export this as a 16-bit PNG file, or sorry, a 16-bit .raw file. And then I believe the maximum resolution is 1024 by 1024 or something like that for the free version. But I was then able to import that into Unity and create a terrain based on it. Now, if we go back to Unity, I actually I'm pretty sure I resized this or something. So it's kind of not a computationally performant way of doing things, but again, I'm a noob. So what I did was just make it smaller. And so really, I think that this is like it has way too many faces, I think, for the size terrain that it is. And so it's incredibly wasteful. So I wouldn't recommend doing it the same way that I did, but the main reason I decided to do it this way is just to see if I could export from Gaia and import into my engine. And of course, that does work pretty well within Unity. Now, I will say that Unreal was a bit more strict with the actual file format. It needed it to be a .r16 file rather than a .raw file, which I think is what I used in Unity. And so the general theme of this, and I've already kind of touched on it a little bit with the armature, but like Unreal is just a lot more strict about certain things. And I think the terrain based on the raw image is another example of that. Also, as you can see, I didn't actually scale this one down. I think I used when you import or create a new terrain in Unreal, you can actually kind of set the grid size. And I think I ultimately removed a bunch of the unused slices or quadrants in the grid. So I ended up getting this much smaller piece here, which is not as computationally wasteful as just shrinking the terrain, but it's still probably not the best way of doing it. I think it probably makes sense to just create a much lower resolution, I guess, terrain that you would see in Gaia. But yeah. So I wanted to try and attempt the same thing in Godot, and unfortunately I did experience a ton of issues doing basically trying to use the terrain tool built into Godot. And then I tried to use Terrain 3D as well, which is a plugin that I think is becoming fairly ubiquitous with Godot terrain. Ultimately, I decided to take the Gaia output and create a mesh in Blender because I could not get Terrain 3D to work the same way that I did in Unreal and Unity. So I basically just took the output from this and then created a new Blender mesh based on that, and then exported it into a format that works with Godot. So interestingly, when I first imported the terrain, into Godot. It did not have a collision mesh, and I found it quite difficult to actually add the collision mesh to the terrain. And I went down kind of a little rabbit hole there and found out if you add a -col to the model in Blender, it will make it a collision mesh, or it will make it collidable. And so that actually worked. And I think I actually had a commenter in one of my other videos mention that as well. So that's definitely an interesting piece of advice that I had no clue about until going through this project. And going back to the slide, the last thing I wanted to mention was just the trees. So I did not model these trees myself. I actually went through to the asset store for all the corresponding engines. And so this one right here and this one right here are from the Fab asset store. And then if I go to Unity, these are both from the Unity asset store. And this actually was in a format that was importable into Godot. I think it was just an FBX, right? So this is actually the same model, but I could not get the texture to work properly. So this is basically just a two color, basically two materials that I added, one to the trunk and one to the leaves, but it is the same model. And then this one is from the Godot asset store. I'm not sure if I did something wrong here, but I just imported this and it looks a little funky, but I did not mess with it too much. Basically, this part of the exercise was to see how robust the various asset stores were. And unfortunately, I would say Godot is pretty lacking in this area. I'm hoping as time progresses that, more and more stuff will be on offer there. But for now, the Unity Asset Store and Unreal's Fab are just so much more full of assets to choose from. So I would say that that's definitely a shortfall of Godot currently. So on to phase 3, I wanted to talk about the coin gameplay. This is kind of where we start talking about code, right? So really what I wanted to do is take in the coin mesh that I made from Blender. It was a very simple mesh. It had a material that was somewhat difficult to get working in the 3 different engines. I used, I guess I used like a mask inside of Blender in order to do like a two-tone kind of thing going on with a dark gold on the outside and maybe a lighter gold on the inside or on the faces of the actual coin. And so that was pretty difficult to export. I actually don't think that worked at all in any of the engines. And that was just I guess it was due to the type of shader that I created in Blender. So I had to like reset everything to be two-tone gold in the engines. So I think I'll go ahead and just take a look in all 3. So you can kind of see it here. I ended up using the same mask though in the engines, so that was kind of cool. At least it worked in Unreal for sure. It basically has that darker and lighter kind of two-tone thing going on. If we go into Unity, they don't actually spawn until I play the game, so I'm gonna just hit start here. And I don't know if the two-tone actually worked or if I just used one singular gold. But I ended up having to use reflection probes in Unity to get that nice little reflection going. I had never done that before, so that was a little new to me. And then lastly, just talking about it in Godot, this is probably a lighting thing, and maybe I should have done something similar to the reflection probe, but kind of without anything at all, the reflection sort of worked. So if I hit play in Godot, and then go ahead and start the game, like you can see when they turn, there's a nice little like I don't even know what you'd call that, but the reflection does occur. It's just not as shiny looking as the other two. So anyway, I did get the coin to rotate in all 3. So the way that I implemented everything with the coin is pretty different in the 3 game engines. So we're going to take a look at the actual coin here, which does have a script attached to it, and you basically see the GD script. We basically have, let's see, I have a variable to talk about the rise duration, so how long it will take the coin to go up into the air. So when the scene starts, what I have is the coin just like flies up into the air. So it'll do that nice little drop down to the earth animation. And that drop duration is 2 seconds. So when I play the game, you can't actually see, but right here at the start, the coins have just flown into the air. And then when I hit start, they slowly kind of drop back down to earth, give you that nice little animation there. But they also rotate on their axis. So I believe that is, yeah, this is quite simple, but it's just in the process, which is, every single frame just rotates right here. There's also some interesting stuff, and I'll go back just to use this as a kind of a guide here. But I also wanted to import the logic to collide with the coins, and then have some kind of message sent somewhere that basically says all of the coins have been collected. So we also have that as well. There's basically an on body entered right here, which is looking for the cube boy. And if so, it ends up creating basically it does a launch coin animation, which sends it straight into the air. And once that happens, then it plays we'll actually talk about this later, but it will basically, I think, yep, there we go. At the end of that animation, it destroys the coin. So all these coins are basically they're all children of this all coins node. And I believe that all coins node is what we actually monitor to determine when the game is over. So as soon as all coins ends up being empty, and I actually don't know why I have two all coins here, but in any case, when that ends up being empty, then the game is effectively over. So I'm not going to go through line by line and all the engines, right? That would take forever. But basically, there is a similar script that exists on the coin inside of Unity. So if I hit play, start, and then pause, right, you'll actually see the coins that show up in that all coins parent empty game object, right? So it works very similarly. And if I were to bring up this script, you'd find that this is actually pretty similar to the way that the one in Godot works. But where we get significantly different is in Unreal, because I did not write a single line of code in Unreal. I use blueprints. So that is something that I haven't mentioned just yet, but yeah, I selected blueprints when I started this project in Unreal, which probably is not the greatest comparison, considering I actually did write and or generate some code in both Unity and Godot. But in any case, you can do all the same stuff, right? So just to kind of show you, this blueprint basically looks to see if the Cuboid character is colliding with the coin in our game mode, and if so, let's see, we call a function called coin collected. We play a sound. I believe there's some animation that takes place here as well. We change the location of the coin, and eventually we destroy the coin. So by and large, the logic is similar. It's just implemented in a much different way. And so just to kind of talk about the blueprints here for a second, obviously I have lots of them, right? They basically control the entire game. So we touched on the character controller, and I don't think I talked about the code for that particularly, but I did want to mention that for the actual movement of the character, a lot of this stuff I could just kind of copy and paste from the default third-person controller inside of, just a new Unreal project that uses a third-person character, so that was nice. But then there was some stuff that I added that was custom, where I add like a speed boost, basically when Cuboy is jumping, and if I hit play, you can tell that he is actually faster while jumping. At least. Yeah, so right there is pretty obvious. That is part of the, I guess, character movement that I did want to implement in all three, is that little speed boost. So, of course, how I accomplish that is a bit different in all three, but you get the idea. So let's talk about the game loop. And basically what that is when the player clicks start, a timer appears on the bottom left of the screen, and then they drop to the ground and actually collide with the ground, and that starts the timer. They can then move around the level and collect all of the coins, and when the number of coins, which is 9, ends up being 0, then the game is effectively won, so the timer stops. And then that's basically the timed game loop. So mainly the one thing that I wanted to show you is the difference in UI stuff here. So I'm going to go back into, we'll start with Unreal because I believe I had that up. So basically have a blueprint here for the start menu, and when you click, it basically has different layers, right? And so I believe one of them is this kind of button here. It says start, and when you click on this, it does a particular action, and that is in the blueprint view itself in the graph. So this blueprint is actually pretty wild. And the reason it's wild is because I think it has some camera rotation stuff. That is one thing that I haven't talked about a whole lot, but the actual cameras kind of vary wildly. And the main effect that I wanted to achieve in all three was that like you have a different view of the Cuboy character when the start screen is present, and then I wanted to blend that camera into the gameplay camera when you hit start. So again, we can just kind of play this so you can see. This is a camera right here, and so that start blueprint that you saw basically starts with us looking at Cuboy from this direction and this camera, and then as soon as you hit start, it blends to the gameplay camera. And that all happens when you hit the start button, and also the UI where you see the timer going in the bottom left and all that good stuff. I believe all of that is here as well, right? So this blueprint does look a little messy, and I'll be honest, it's kind of easier for me at times to follow code than it is these blueprints because it just gets pretty insane. So I'm not sure if you can do the exact same thing in C++. I think that you can, but again, I selected a Blueprint project and not a C++ project, so I just kind of had to follow I guess, the sequential nature that you would follow in an actual, like, a script, which I guess is kind of what this white wire is, right? This is the actual sequence. So this happens, then this happens, then this happens, then this happens, so on and so forth, all the way to the end here. And let's see if we can. Yeah, so this is us. Okay, we call a has game started, and I believe that's what starts the timer. I think there's actually an invisible stand that I end up destroying at some point, and then I set as on stand variable to false, which then allows me to drop all of the coins from the sky, and then effectively the game has started, right? So then we see the timer here as well. So yeah, this is a very convoluted heads-up display, and I probably could have done this a little bit more elegantly, but we'll take a look at what that looks like in Unity really quickly as well. So I have a UI game object, and there is a start overlay that I believe is by default disabled until you actually no, it's going to be enabled by default, and then it's disabled when the game is played. But then conversely, the win overlay is disabled until you've actually won the game. But we can kind of take a look at what this looks like. So there's a start overlay and then a start button. I have my custom font in here that I imported, and that worked just fine. Nothing too crazy. This and Godot are fairly similar in how they work. So I'll just show you what that looks like as well. I have kind of that stopwatch here, and then there's an elapsed time that starts as a default. And then I had my script that basically talks about the changing the font size and the font color as well, kind of drifting toward that red color. Yeah, grow the text by 50% over 10 seconds. And some of these comments are always a little, you have to take them with a grain of salt because I change the variables and then forget to change the comments. So the comments are actually wrong. So forgive me if that's the case here. But yeah, so when you actually win the game and the timer stops, you call the stop timer function, and then you show this win layer, which is actually just right here. And the win layer, one thing that was a little obnoxious with the, I guess, Godot side of things is the fact that, like, you had to have these things parented and stuff. And I'm sure there's a reason for that, but it just was a little obnoxious and conceptually a little hard to kind of wrap my brain around things. But again, I'm the least skilled in Godot of all three of these engines, full disclosure there. So we will move on to phase 5. So we talked about the start timer. We talked about the timer as a stopwatch until all coins are collected. And then I think we actually already talked about this entire phase. So we'll go ahead and move on to the final touches. And so essentially what happens is it's kind of hard to tell, but like I told you that the timer drifts toward a red color as the time progresses. And so I actually send the exact hue of red to the win display in all three engines. And so if you beat the game in more time, it will be more red. If you beat the game in less time, it will be less red. We will play the Godot version really quickly just to show you. But yeah, so it's white, right? And then it's kind of drifting toward this dark red color. And I guess I did a really bad job on this one because it's going to be bright red. But there is a little bit of frosting here, like an overlay, so it kind of looks different. But that is actually the same shade of red. And if I were to beat the game faster, hopefully, I'm really bad at my end game here. Yeah, so it's actually a little bit lighter. It's kinda hard to tell, but again, if maybe I did a better job of, like, making this turn red over 20 seconds, it would've been a little bit more obvious, or if I did a different color scheme anyway, but I thought that was kind of a cool effect, and again, the other thing that I do in this kind of win, screen, if you will, is give the player the ability to play again, which kind of resets the entire thing. And that actually brought up an interesting problem in and of itself, because different engines kind of handle like a reset differently, right? So I had this main scene, and there's a couple of different scenes in the Godot project, right? But the main scene itself is kind of what you see here, but it is not the scene that loads when you play the game, right? You actually load the start scene. So if I were to hit play, the scene that I've defined as the scene to load first or whatever is what loads, and in this case is the start scene. And when I hit start, it actually loads main, and my main scene, as you can see, is that start scene.tscn. So in this, it's actually pretty easy to restart it, right? Because I know that when my game starts, it loads start scene, but then as soon as I hit start, the start button effectively loads the main scene, right? So if I want to restart the game, I just load the main scene again. I never go back to start. But in Unreal, that was like way more complicated. And again, I'm complete noob, right? So what I had to do is like, I think basically I implemented this idea of a game mode. And so like when the win condition gets hit, I think what I did was basically so within my blueprint for the win screen, so I have that play again button that rotates kind of back and forth a few degrees, right? I basically do a quick restart, and that quick restart is a whole different way of loading the game. Like it doesn't reload a scene the way that Godot does. Yeah, so that is actually in the third person blueprint itself, right? So I think what we do is we just kind of do a quick version of what we do in the start menu blueprint. And to be honest, like this was like 2 weeks ago, so I kind of forget exactly what I did here. But long story short, it kind of soft resets the game, if you will, rather than just reloading a scene the way that we do in Godot. And I think that's largely how this works as well, is it just kind of reloads our scene from scratch. And the last thing I want to talk about really quickly is sound effects. So I used the Brackeys platformer sound effects. So thank you to Brackeys for making those available to budding game developers such as myself. I basically added them all the same way, right? You just kind of trigger a sound to play when a given thing happens. So one example of that is when I jump. So finding, the actual element in your character controller, be that a script in Godot and Unity or Blueprint in Unreal, basically where you perform a jump, you can just add a play sound effect right there with a jump sound. And then on top of that, the coin makes a sound when the coin is collected. So whenever you call a coin collected method or do something similar in that kind of area of your game logic, you would just call the coin And in the intro demo of the video, I just had some lo-fi playlists playing in the background, so I cheated in some music even though I don't actually have any music, in the game at all. But yeah, so kind of a little wrap up here. Just wanted to ask myself a few questions after the process, right? Because this did take dozens of hours to get to the point where the game is playable on all three engines. And I really wanted to kind of say, is there a winner in this, even though it doesn't really matter? But the main question was, if I decided to extend this game and I decided to put an extra month into it or 2 months, which one do I feel would allow me to get the furthest? And my answer is Unity. The reason is probably because I've already developed a full game, even though it's just a solitaire game in Unity, right? And I've done that from start to finish, and because of that, I just have more hours in the engine. But again, and I have this as kind of a outline in the top right here. You should definitely use the engine that best fits your project. That said, there were a few things that the other engines wanted, like Unreal, I think looks the best. I think that's probably not a surprise to anyone. I think the engine that provided the best game feel, I actually really like the way that the character controller worked in Godot with my game. I felt that I had, and again, like these are parameters that you can probably like edit so that they're all pretty much the same, but with a very simple character controller in Godot, I just felt like my movement was the best in Godot. If I were to take Cube Boy and I were to expand on it, I think I'd probably start with the Unity project. I might implement some of the logic that I did a little bit differently in Unreal or Godot, and I might try and copy the game feel that I got in Godot, because again, I thought the character controller just felt better in Godot. But that's overall my conclusion. I know that I probably did a lot of things wrong. I've probably shot myself in the foot like dozens of times here, but that's kind of the entire point of this, is to learn. Hopefully this is helpful to you in your decision process going forward. Thank you for watching.